Welcome, everyone. We're about to begin our data carpentry session here on the second day of the HPC in the City St. Louis Hackathon. It is my esteemed pleasure to introduce Ms. Anna Dabrowski, one of my coworkers at the Texas Advanced Computing Center at the University of Texas at Austin. She is a coworker that loves data, and her experiences and her knowledge, well, when we're in a room, when she speaks, people listen. And so we're very fortunate to have her here. And so without further ado, I will close my mouth and hand the floor over to Anna. So Anna, you have our attention.
Thank you very much, Jamie. So today I'm going to talk with you a little bit about using Python to clean your data, and we'll be working in a Jupyter notebook. So I'm going to go ahead and share my screen. Make sure I have the right screen shared. All right. So you should be able to see my screen now. This is the GitHub repository that I'll be working from. So we put that in chat for you all. You are welcome to follow along. If you're using GitHub and you know how to grab a repo and you know how to bring up a Jupyter notebook, please go ahead and do that. If you want to follow along as a demo, you can also do that, and I'll do some live coding and you can follow along that way. So my session today is going to be just an hour. So we're going to be really quick with talking about how you can clean data in Python. And if you were able to participate in Lisa Pearson's presentation earlier on moving data into dashboards, she talked a lot about data cleaning and how data cleaning is a really large component of working with data, especially if you're reusing someone else's data. You need to clean it oftentimes, you need to transform it oftentimes before you can actually do what you want to do with it. So we're going to talk about some steps for doing that kind of data cleaning. All right. So if you are in the GitHub repo, we're going to be working inside of this folder, the 2021-1105 Hack HPC folder. And that's where you'll find the notebooks and other materials that we'll be using. I'll just give you a quick walkthrough of what's in here so you know what to look at. When I'm sharing my screen, I'm going to be walking through the data cleaning with Dataframes notebook. This one has a little bit of content filled in, but then it has empty spaces so you can write in your own code and run it and see how that looks. If you just want to see some worked examples where all the code is already pre-written for you and you just want to run the cells, you can go into the worked examples notebook as well. So that has everything filled in. You can use that as a reference in the future as well. There's also an HTML version of this notebook. So if you are unable to bring up Jupyter notebooks, but you are able to grab this repository and you have this file, you can always open that up in your browser and you will see the notebook in your browser as well. You won't actually see the code running, but you'll be able to see what we're talking about. All right, so I already have my notebook up and running, so I'm going to get started. This is my data cleaning with Dataframes notebook that we just discussed. And we'll be working with data using Python in a Jupyter notebook. So before you get started, if you are trying to follow along, I recommend grabbing the environment YAML file so that you'll get all the packages installed that you need to run this notebook. Again, that is in the GitHub here. It's the environment YAML file. We also have some crime data that we'll be working with in the crime data folder. And we have data about neighborhoods in St. Louis that we'll be working with as well. All right, back to my Jupyter notebook. So today we're going to focus mainly on data frames as the data structure we're going to work with in Python in order to manipulate and to clean our data. And so data frames are basically tables, but data frames are a data structure that you get from one of the packages we're going to work with. and they allow you to do a lot of things with your data. They just make it a lot quicker and easier to manipulate, transform, and do different things with your data. So you'll see what I mean in a moment. The reason we're working with data frames is because they're excellent for tabular data. And you will most likely encounter a lot of tabular data, depending on what your project is, what kind of data you're working with. You may have different sorts of data. You might have data that's in tables in Excel files. You might have data that's in CSV files, comma separated value files. Maybe you're using Google Sheets and you have some tables in Google Sheets. Maybe you're trying to access a database, or maybe you need to extract some tables from within PDF files. So your data can be in different places, and Python can help you pull data from those files and then work with that data to clean it up, transform it in the way that you need for the particular application that you want to build. So I took some time to look around for data about St. Louis, and I found that the St. Louis Metropolitan Police Department has released some crime statistics data on their website. I have a little screenshot here of what the website looks like. It's not very pretty, and it looks like they are sharing information in PDF files. So you can download data about crime stats by neighborhood, but everything is within PDF files. So let me show you what that looks like. In my crime data folder, I have some PDF files that I downloaded. And the data actually look like this. There are tables giving you statistics by neighborhood of different kinds of crimes that have been reported in different months, and the year-to-date counts of those kinds of crimes that have been reported, but they're all stuck in these PDF files. So you have a PDF file that's 178 pages long, and you can't really do much with this data when it's in a PDF file. You can kind of read it, you can search, you can maybe copy paste from it, but you can't do anything really to work with this data in mass when it's in a PDF file. So what we're going to do is we'll try and extract that data from the PDF file. And the reason we want to do that is because when we can pull that data out of the PDF file into a data frame, into a structure that we can manipulate, we can then do all sorts of things with the data. We can do statistics, we can make comparisons, we can build graphs, we can make maps. We can do a lot more with the data than we can if we're just reading the data from a PDF file. So one thing that we might want to do is extract statistics about a particular type of crime and compare across different neighborhoods. That's not something you can really do within that PDF file. You'd have to scroll through these 178 pages. You'd have to find search for the neighborhood you're looking, maybe copy paste some pieces of data and maybe put those in Excel or something like that. It's just a big hassle to try and work with the data when it's in a PDF file. You might also want to look at changes over time and compare all the months so far side by side. You may have noticed that each PDF file, or this particular PDF file, is just July and August data. And the data for January and February, March and April, those data are in different files. So they're completely separate files, and you can't really merge and work with those data together when they're in different PDF files. And then finally, maybe you want to visualize the neighborhoods and their statistics on a map. You can't really do that when you have this data trapped in the PDF file. You have to extract it all, and then you have to merge it with some geospatial data in order to be able to put it on a map. So see, these are some of the things that we'll cover, enabling yourself to do by using Python in order to pull information from files. So I'm focusing on PDF files right now because those are the hardest to get information out of. You're going to have an easier time with CSV files or Excel files or databases because things are already structured as tables. You'll likely still have to clean your data a lot, but it won't be as hard to pull the data out of those files. Alrighty, so I went ahead and downloaded the crime stats for July and August, and that's the file that I was just showing you, from the police website. And that file is named NIBRS 001-N210708. That got saved to my computer locally when I saved it, and then I moved it over to a place that's accessible for this Jupyter notebook. So we're going to make things easy. So I'm going to assume that you have packages installed already on your machine locally or wherever you're running your Jupyter notebook, but that is a step that you'll have to take before you'll be able to import those packages and use them with your code. So here, the first cell that I have with my code is a cell running imports of different modules that I know I'm going to use. So these modules are going to help me work with the data. We have pandas and numpy, which include a lot of functions and objects, especially the data frames I've been mentioning, that help you to work with the data. They make it easier to work with the data in Python. We're going to import tabula. This is a module that is magical, and that will help us convert the tables that we have in the PDF file into data frames or CSV files automatically. So that is an awesome tool, especially if you're working with data that's stuck in these PDF files. I'm also going to import geopandas. Hopefully we'll get to using that today. Well, depending on how quickly we move, we might get to work with a little bit of geospatial data. But geopandas helps you to work with geospatial data within data frames as well. And that's really neat when you get to actually visualize things on maps. And then we'll also use matplotlib to help us make visuals. So if you are running this in your notebook, I'm going to walk through the steps that I'm taking, and feel free to follow along or just treat this as a demo. So in order to run this line and import all of these modules into my workspace here, I'm going to click on this cell and press Shift-Enter. And you'll see that it's running with the little star. And when it's done running, you'll see a number that says that this cell has been run. I see no errors, so it looks like everything worked. So step number 1 is going to be creating a data frame directly from a PDF file. So the first thing that I have here is a line that specifies what is my PDF file and where is it. So the first step I'm going to do is make this data frame object that contains the tables that the tabula module is able to extract magically out of this PDF file for me. So again, I'm pulling the file that is in crime data and is named this way. And if you look inside my Finder window, you'll see that I'm running my notebook from here and my data is in crime data, and we're going to pull in that file. So I'm assigning this string, that's why it's in quotes, because it's considered a string, to a variable that's called aug PDF file. And now I'm going to actually open that file. So I will create an object called DFS, and I'm going to make that my data frame. And I'm going to use the tabula module in order to read the PDF file. So what I'm doing here is I'm running a function called read PDF that belongs to the tabula module. So I need to specify the module I'm using and then dot read PDF. And then I need to tell read PDF what file I want it to read. And that's going to be this aug PDF file. So I specify that. Aug in this case is for August _PDF _file. So I tell the module which file to pull in order to extract that table for a data frame for me. And I can give it different sorts of information as well. So I can tell it what kind of file encoding to expect. So in this case, I'm going to type in encoding equals, and then again in quotes, UTF-8. And I can tell it which pages to look at as well. I'm going to write pages equals, let's just look at page number 1, because there are 178 pages, so that can take a while. So let's try and make a data frame out of this OGG file. We tell read PDF what kind of encoding to expect, and we tell it which pages to look at. And then once we have that, let's take a look at what we have by just including the variable name again here. So because we're working in an interactive environment, if you just type the variable name that you created here, you should see its contents. So here, I'll press Shift Enter to run this line. Cool, something happened, but it doesn't look like any data to me. So what I see here is that I have an empty data frame. What I actually have is one empty data frame and another empty data frame. So in brackets, we have a series, and this series is 2 empty data frames. So Tabula tried to read this PDF file, tried to extract the table it found on the first page into a data frame for me, and it failed. So it looks like I didn't give Tabula enough information in order to know how to interpret this PDF file. So we're going to do this again, but we're going to give Tabula a little bit more information. So here I already have the same code written out. We're going to create another data frame object using the same function, and we're going to read that same file, except we're going to give Tabula a little bit more information about how to interpret that file. So if we do OGG, and here you can try and use double tab to do auto completion, which makes it a lot easier and faster to write your code, so you don't have to type in long names of variables. So I just did tab completion there. So I'll tell Tabula, read this PDF file. I'm going to go ahead and just copy paste this same information from the top. I still want it to use the same encoding. I want it to look at page 1. But now I'm also going to specify which part of the page should it look at. So this can be a little bit annoying to figure out. So I'm just going to go ahead and include the coordinates for this particular PDF file. So let me copy those here and paste them here and just walk you through what this is saying. So what I'm telling Tabula to do is to look at this file, look at the first page, and look at this part of the page in order to find a table. And what this part of the page is, if I go and look at my PDF file and open that up, I'm on page 1. I'm telling Tabula to look at this page, and I'm going to specify some coordinates on this page that I want Tabula to look at. And so I'm specifying coordinates on the page based on the different corners that I want Tabula to look at. So these numbers are the corners here that I'm telling Tabula to look at, because I'm telling it this is the part of the PDF file where there's a table. And this is why extracting tables from PDF files is kind of complicated. It gets a little bit messy. You have to be very specific about these coordinates as well. Because I just want this to work, I'm going to give you the area for this particular data set. And then I will also specify how I want it to build the table. I'm going to say stream equals true. Let me put that on another line just so you can see it all. And we'll look again at whether or not we actually get a data frame. Shift Enter. I included an extra comma here, so I'm going to have to get rid of that. Shift Enter again. All right, now we actually got some data. Awesome. That was really messy. That was kind of complicated. You're just going to have to trust me that this was the right place to look on this PDF file. But if you are working with PDF files, you're going to have to figure out how to find that area. So it's not really pleasant to try and get data out of a PDF file, but you can do it. And Tabula will help you to kind of pull out that information, and then you'll see some of that tabular data. Now, one thing I want to note here is that you are seeing a series of data frames here. That's why it looks kind of ugly in our window. And that's why we have this square bracket here at the beginning. So if we just want to look at a single data frame, if we just want to look at the first data frame in the series, we can do that by typing our variable name for the data frame. That's DFS and 0, and then pressing Shift Enter. Scroll down there. So now we see the data frame that we extracted from the file, just one data frame. Again, this can be kind of a messy process. Tabula is going to try and identify one or more tables within your file. So you have to specify like which sheets should it look at, which part of the sheet should it look at, how many tables do you want it to extract. It gets very detailed and pretty complicated. But here we were actually able to extract some information from this PDF file. And we're able to look at this data frame. One thing I do want to note is when you have a series of objects in Python, Python uses what's called zero-based indexing. So that means that the first element in your series is actually number 0. The second element is actually number 1. And the third element is actually number 2, and so forth. So that's why if we want to grab the first element, we use a 0 here. Now, one of the reasons I wanted to go through and kind of show you how complicated it is to pull things out of a PDF file is really to encourage you to never share your data in PDF files, and to kind of show you why it's so complicated to work with data in PDF files, why it's not great if someone else is sharing their data in PDF files, and how maybe if you have a little bit of skill in pulling this kind of data out, you can help other people to be able to work with and interpret that data as well. So there is a way to be lazy with PDF files, or a little bit lazier, that I would encourage you to use, so you don't have to go through this whole complicated process. Tabula actually has a graphical user interface app, and I have a link here to where you can download and use that. And what that lets you do is to actually look at your PDF file, choose that area you want to use, change those parameters in a kind of graphical interface, and go ahead and download just a CSV file, a comma separated value file with your table directly. So just to show you what that looks like, here's the Tabula screen. If you're using the GUI software, you can actually specify the area you want it to look at, and you can give it other parameters, and then you can run that and get a table in a CSV file directly. That'll make it easier to work with the data. So oftentimes, if you're working with tabular data, ideally, you're already working with it from a CSV file, from an Excel file, maybe from a Google Sheet. So you already have that table within columns and rows so that you can already work with that data a little bit more easily. So this is going to be our starting point for cleaning up the data. Since we only have an hour, we're going to move on pretty quickly into cleaning up the data, because as you saw, even here, when we pulled out this table, cool, it took a while, some effort to get the table out. But even though we got that table with Tabula, it's still messy and doesn't completely make sense. And we still have a lot of cleaning work to do. So just to simplify things, we're going to start with a CSV file. So I've already pulled the data out of this PDF into CSV file for you. And that is also available in that crime data folder. So we're going to start working directly with cleaning up the data from that CSV file. One thing I also want to note is that, and this is something I think Lissa brought up in her presentation as well, it is great to work with static files. So a file that you have saved locally on your machine, or you have saved somewhere else that you can access in order to build something like a dashboard. So you can have that file saved somewhere, you can pull information from that file, transform it, and then push it to your dashboard if you'd like. The one limitation with that kind of data is that if you need to update the data, you're going to need a workflow earlier on for updating that static file every once in a while, so that when you read from that file, you're getting newer data. So if you are working with data that gets released incrementally, you may want to go directly to the source of the data and pull directly from that source. And there are tools in Python to enable you to do that. So I've included a couple of links here for that. For the purposes of this presentation, we're just going to focus on working with files directly, but you can access databases and you can access data available through APIs directly using your Python code. So that's another way to pull in your data. Alrighty. So let's get started with pulling our data into a data frame from a CSV file and then actually cleaning up that data. So I have a CSV file that has crime data for August structured as a table. Again, I used Tabula to pull that out of that wonky PDF file. I saved it in crime data. And then I wrote out that location for myself so that I can have Python look there to pull that CSV file in. I assign this to a variable that I can then use. All right. So I'm going to create a data frame object with the data in the CSV file. So this time I'm going to call my data frame crime_df. That's the variable name I'm giving it. You can name it whatever you want, but I want to be kind of clear what's in this data frame is crime data. And then I'm going to use pandas, so pd dot read _CSV. So you'll see I'm using a different function this time. The first time I used tabula in order to read my PDF file, and now I'm using pd.readCSV file. So PD here stands for pandas. When I imported pandas, this module, I imported it as PD. I gave it an alias so that's easier to type when I use it. I'll just scroll up and show you what that looks like. So here's where I originally imported pandas. And when I wrote my import, I said as PD. So anytime I want to use a function from pandas, I can just write PD instead of needing to write pandas. All right, so I'm going to create my crime data frame by reading from a CSV. And this is the file that I want to use, the August CSV file. Just going to copy and paste that in there. And I'm going to tell pandas that I do not want it to create a header for my data frame. I'm going to create my own header, and we'll go over what that is in a second. All right, so we'll create this, and I'll just also take a look at it once I've created it. So if I press Shift Enter here, I will see that pandas read the CSV file for me. It made a data frame out of it. So we now have our data frame object here. And then when I asked it to show me what that looks like, I get this visual of what the data frame looks like. So I see that here at the top, I have columns that are named 0, 1, 2, 3, 4, 5, 6, 7. So the reason I have columns that are named this way is because I said header equals none. If I exclude this line, pandas is automatically going to take the first row, and I'm going to rerun this. Pandas will automatically take the first row of my data and make that into the header, and those will be my column names. But because this data is so messy, I don't want it to try and interpret what the header is. I'll define that myself in a little bit. And I'll just rerun that. So my crime data frame has column names 0, 1, 2, 3, 4, 5, 6, 7. It also has row indexes here on the side. And you'll see that the row indexes go to 4, then there's a ... There's a whole lot of data in between, and then it gives me the last rows of my data frame. Because it's so big, it gets truncated, and you just see the first and the last part of the data frame. Here at the bottom, we actually see how many rows we have. So we actually have a lot of data in this table. It's 15,000 rows, over 15,000 rows of crime stats that we're working with. So one of the great things about working with Python to manipulate your data is you don't end up with an Excel spreadsheet with 15,000 rows that you're trying to kind of find where you need to change things. You can do everything programmatically, and it'll kind of apply to this whole giant data frame. All right. So the first thing I'm going to do, since I did not import a header with the data, and I just have these numbers as my column names, I'm going to go ahead and assign some column names that I think are appropriate for the data. So this is something that you can do once you've looked at the data a little bit and maybe understand what belongs in each column. I've taken a look at this data, and I've created what is called a dictionary that tells me what I think each column name should be. So I think that column 0 is the crime category. So it applies to a person, or in this case, maybe nothing. We'll have to figure that out. I think column number 1 is the crime type. So we have murder, we have manslaughter, we have runaway, we have other offenses. So I'm calling this column crime type. Once we clean it up, that's what we'll have in there. And then we see that we actually have some header information within this table, but it occurs kind of all the way down on row 2, where we have information that actually column 2 is supposed to be this NIBRS number, column 3 is July, column 4 is August. So we actually have some column information kind of within our data here. We don't want it there, so we're going to clean that up, but I can use this to name my columns, because this actually tells me what data are supposed to be in these columns. So I've gone ahead and created a dictionary that maps the original name of the column as I've imported it to the new name that I want to give it. So dictionary in Python is a data object that contains a series of key value pairs. So you define a dictionary with these curly brackets instead of square brackets, and then you give it a key, a colon, and a value. So you get this pair, and then a comma, and your next pair. So we'll see how that gets used to rename our columns here in the header. All right, so I've written out the column names as I think are appropriate, and then we're going to transform the data to make sure that those data that belong in those columns are within those columns. All right, so in order to change the existing column names, I'm going to write the name of my data frame, crime_df equals my data frame, and rename is the function that we're going to use. So we're going to rename something in this data frame. And then we have to say what we want to rename. So we're going to rename the columns. And we'll use columns equal column names, this variable here. Underscore names. And then we'll take a look at what that looks like. So now we have new column names. So we've changed up the column names to what I think are appropriate column names for the data. We have crime category, crime type, NIBRS code, etc. And the reason that we want to do this is because then you have some meaningful names for your columns for what kind of data you anticipate in those columns. And when you're using Python to work with your data, you can refer to data within columns by using the column names, and you don't just have to use these numbers or these indexes here. So this makes it a little bit easier to then work with your data when you want to pull it out of columns. One thing I do want to show you as well is, so far when I wanted to look at this data frame, I've just been typing the name of the data frame, and it kind of gives me this view of what's the whole data frame with kind of the middle part missing. I can also specify, if I want to see the top portion of the data frame, how much of that data frame I want to see. So how much of the data I want to see in my table. And you do that with a function called head. So I want to see the head, or the top portion of my data frame, and then you can tell head how many rows you want to see. So in this case, I'm going to look at 30 rows. I'm just going to go ahead and rerun this, even though it includes my renaming. And now when I look at the data frame, I just see the first 30 rows of the data. And again, the reason that you see this going only down to number 29 is that these rows are indexed, and indexes in Python start with 0. All right. So we finally have our data frame in Python, and now we're going to try and clean it up a little bit. So this process can take a little while, but in order to clean it up, we have to identify what is wrong with this data. So let's take a little bit of a look at what we have here in this data frame. All right, at the top, I have my header with the column names that I want to use. And what I want, ideally, is one kind of value within each column. But what I see here is that I have some columns that have a mix of different values. So for example, we see that crime category contains a category, but also contains this word neighborhood. And so on row 0, we see crime category has neighborhood, and then the crime type is academy. So this isn't actually crime information. This is neighborhood information that's occurring here. And this is information that belongs in its own column. That information shouldn't be in a row here. It should be in its own column because it's not a crime type. It's not a crime category. So the first thing we're going to do is actually pull out this neighborhood information and give it its own column. So we have that neighborhood information here. At the moment, we don't see it repeating. If we look at more of the data, we would see it repeating as well. But in this case, we have row 0 gives us the neighborhood. Then we have a crime category that is person. And then the rest of our columns don't have any values here. So this is just specifying the category of crimes. And then we have, again, this kind of header in the middle of our data. And that's not actual data, that's just information about the data. Ooh, excuse me. And then finally, we have the data that we want within the table. So we want to know the crime type, and we want to know its code and the number of crimes that happened. So this is the actual data that we want to keep. But these columns or these rows are kind of extra, and they're messy. We also have additional rows here down at the bottom that give us some totals in the middle of our data. We don't need totals in the middle of our data. We can calculate those ourselves. We want to take those out and just have the data itself. So we're going to clean this, this data set up a little bit. You see again that you have this crime category repeat, and then again you have empty rows here, and then again you have a repeat of the column header originally. So the reason this data is so messy is partly because it came from a PDF file, and for every page of the PDF file, that header got repeated, and every page had a totals calculation at the bottom. And so now we have that data within our table, but we don't need that information in our table. We just need the actual crime stats data. So we're going to clean this up a little bit. Alrighty, so we'll begin tidying the data by identifying some problematic patterns, and we just talked about a few of those. So one thing that we need is to have values for a single variable within each column. So what we have in the crime category needs to be a category for crime. What we have in crime type needs to be a crime type, not the name of a neighborhood. We also need to fill in missing values for columns where we know what should be there. And what we have here are a lot of missing values for the crime category. This data is actually grouped by crime category. We have person crimes here, and then we have property crimes here below. But these rows don't actually include that information. It's just here in this one row. So what we want is for each row to have a category as well. So we need property to occur next to robbery, and property to occur next to arson. And the same goes for person. We need person to occur next to murder or manslaughter, and not just here, in order to make our data more usable. We also don't need these repeating headers that we were just talking about, where we have the NIVRS July, August diff change header here in the middle of our data. Then we have it again in the middle of our data. And we know that this will repeat many, many times in this data set because we downloaded 178 pages of PDF files that repeated these headers. And we also don't need these repeating calculations that happen within our data. All right, so we've identified some issues with the data and we're going to go through and clean it up a little bit. Okay, so the first thing we'll do is create a new column for that neighborhood data. We want to extract that neighborhood data from happening within these rows every once in a while. We want to give the neighborhood data its own column. So to do that, I'll first create a new column. So in my crime data frame, I'm going to specify a new column called neighborhood. And so I'll specify that with square brackets and then in parenthesis for that column name. And that column, I have to tell Python what values to put in that column. And right now I want it to be empty when I start out. So I'm just going to use np for numpy.nan. So this is not a number. This is an empty value. And then I'll take a look at my data frame to see what happened. Great. I have another column now called neighborhood, and it's empty. Now what I need to do is get the neighborhood information out of this crime type column into this neighborhood column. So then we can clean this crime type column up and only have crime types within the column and not neighborhood names within that column. In order to do this, I'm going to use a tool called a boolean mask. So boolean mask is a way to use logic to help you identify particular parts of your data. So let me show you what that looks like. I'm going to create something that's called a mask, and I will give it some values. So I'm going to look at the crime category column, and I'm going to find every row in the crime category column where the value is neighborhood, because I know that in this row, when the value is neighborhood, my crime type column will actually tell me what neighborhood it is. So first, let's identify all the rows where we have neighborhood within crime category. So we have our crime data frame. We look at the crime category column. And we want to look at the values that are called neighborhood. So let me just copy and paste that value here. So what this says is find all of the rows within the crime data frame where you have neighborhood as the value within this crime category column. And what this is going to give me, if I just go ahead and run this and then print it out, take a look at it, is a list of true false values. So this gives me information on whether or not Python finds neighborhood in a particular row. So for row 0, it's true. For row 1, it's false. Let's take a look at that. Here, if I look at my data frame, for row 0, yes, it found neighborhood. For row 1, no, it did not find neighborhood in that category. So the mask gives me these true false values, but then I want to actually extract those rows from my data frame. So I need to apply this mask back to my data frame. And let's do that. Should we do that on the next? Let's do that here. So we'll take our data frame, and now we just give that data frame the mask within square brackets. So the mask is actually some true false values for which rows you want, and then you tell the data frame which rows you want. So let's take a look at what that looks like. So when I pull that information out, now I'm only getting the rows from my data frame where crime category is neighborhood. And I can see what those rows all look like. And then I see that when crime category is neighborhood, crime type is actually our neighborhood name. So this is the information we want to take out and put in our neighborhood column. We want to know the neighborhood name for all of these. All right. So in order to pull this information out of these columns and put it into its own column, we're going to write a little bit more code. We're going to say, update my neighborhood column with the following. Go into the crime data frame and pull out the value in the crime type column, because that's our actual neighborhood that we want to go into this column. And pull out this crime type dot where the following is true, where our mask is true. So this is the same mask we used here to identify these rows that have the neighborhood within crime type. And everything that you don't match, just keep it empty and don't worry about that. All right, so now let's look at this subset of our data frame again and see what happens. All right, so our code went in and gave us the neighborhoods from the crime type column anywhere that the crime category had neighborhood in it. So now we have the neighborhood values within their own column, and we don't need to have those neighborhood values within our crime category and crime type. In fact, we want to remove them from there because the crime category should only be crime categories and the crime type should only be crime types. So we can also take a look at all of the neighborhoods that we have here in our neighborhood column. If we do crime_df and then neighborhood dot unique. So that's a function to give you all the unique values within a column. And if I run that, I'll get a list of all the neighborhood names that I now have in my neighborhood column. So it looks like we got a lot of different neighborhoods moved into the neighborhood column. So even though when we look at the data frame here within our interface, we only see a subset of the data. We see that we have Academy, Baden, Wilmore Park. We don't see all of the data. We can take a look and see that we actually have a lot of neighborhood values that got moved into that neighborhood column. Okay. So another thing I'd like to show you how to do is how to subset your data or look at specific rows of the data using the row indexes or the row numbers for those data. So if I want to look at, some of these rows that happen here in the middle that get excluded when I just look at the data frame, I can specify to Python exactly which rows I want to look at. So I do that with something called iLook. So I'll take my crime data frame again, and this time use .iLook. And here in square brackets, I will tell it which rows I want it to give me. And so if I run this, I'll see rows 89 to 139. One thing to note here is when you specify a slice of your data, it is exclusive. So it includes the first value, but it's exclusive of the last value. So if you want up to 140, you actually have to say 141. This will give me up to 139. What I wanted to show you here is that we have the neighborhood values from the crime type, but they aren't included for all of our data. So we just have a row that includes Academy as the neighborhood here. And then when we scroll down, we have Baden as the neighborhood here. But what I know when I look at this data is that all of these rows, these all have Academy as their neighborhood. And everything all the way down to the next neighborhood is all for Academy, is all data about that neighborhood. And then when we reach Baden, all of this data that keeps going down is for that neighborhood. So I want to actually fill in this column with Academy when Academy applies. So I want Academy for all of these rows for row 90 all the way to 133, and then Baden for 134 until we have the next neighborhood. So we can do that by downfilling values. So we're going to use a function called ffill in order to fill down the values in the neighborhood. So every row of data actually has a neighborhood associated with it. And we don't just have one row here and then a whole bunch of empty values. We want every single row of our data to have a neighborhood so that we know which crime types are associated with which neighborhood. All right, let's do that quickly. And then it looks like we are at time and I will have to wrap up. All right, so I will take my neighborhood column again. So crime data frame and then neighborhood. And I want to update that. So I'll just copy that here and paste it again. So take my crime neighborhood and use this ffill function. So ffill will downfill the data for me. So what I'm saying is downfill data in this column and apply it to this same column. So now when we look at our crime data frame, we actually have all the neighborhoods filled in. So now we have Academy filled in, and we have the other neighborhoods filled in for all the rows. If we want to look at the same slice again, you can go up here and rerun this. And now we see that the neighborhood is Academy until we reach Baden. And then the neighborhood is Baden for all the other rows. So now we have our data with the neighborhoods and with the kinds of crimes that happened in those neighborhoods. Unfortunately, we are on the hour now, and there's a lot more cleaning that needs to happen. So this notebook, if you looked at the worked examples notebook, will give you the code to keep on cleaning the data in the way that I've described. So we do want to kind of remove these neighborhood pieces of information from the rows because now they're redundant. Now we already have the neighborhood here. We want to remove these headers and these other calculations. And the Jupyter notebook will walk you through some procedures to do that. Unfortunately, we don't have any more time to do it live, but I'm happy to answer questions by email about cleaning up data or in any other way.
All right. Thank you so much, Anna. Now, I want to open the floor up for any questions to Anna, because I know she gave quite a bit of information, and then I gave information in chat and on Discord. So are there any other questions for her? I know many of you all are going to be cleaning up data sets.
I know it's very fast, and we actually didn't even get to clean it up very much because we spent so much time trying to pull it out of that PDF file. But this hopefully gives you a sense of how much effort data cleaning can be and a little bit of what you need to look for when you're cleaning the data. And then just know, like, Python and these modules can help you do magic. So if you want to do something, the internet is your friend. You can look up a lot of different functions to enable yourself to do a lot of this cleaning work.
I'm checking Discord.
Yeah.
Checking there.
Yeah, I got a quick one. And you probably don't even need to go back to your slide. So I'll just, because there are 3 consecutive questions, but you probably don't need to go back to slide for any. Now, the first one is when you read the PDF file, the UTF encoding, did you have to explicitly say that there, or it can default to it?
It can default to it, yeah. You don't have to specify the encoding.
Okay, the second one, very quick. The area coordinates, did you manually put that there, or did they read it for me?
Yeah, so I did it here. I just copy pasted it. The way I did it originally was I actually used the GUI interface in Tabula. And if you use that interface, it'll tell you the coordinates it's using in order to extract the table. So I just took those coordinates that I used in the GUI interface when I knew it worked and did it in Python here in the example. And the reason you may want to do that is that even if you're using, let's say you use the graphical user interface on one of these PDF files, it's 178 pages, you use the graphical interface to help set up, like, here's my table, extract that table into a CSV file for me, thank you very much. Once you know where you need to tell Tabula to look to extract that, you can apply those same coordinates to future PDF files. So I know that these crime reports are released every 2 months by the police department. And if I actually write those coordinates in my code, I don't have to go back to the GUI and do it through the GUI every time. I just rerun my code over the new PDF files. So it's still beneficial to put in the code sometimes.
Okay, very good. And the last one, very quick, the variable for the Boolean value, I think it was for neighborhood.
Mm-hmm.
Mask, is that a reserved variable name, or I could use anything else? Mask.
Oh, you can use anything else. I use mask to be explicit because it's called a mask when you apply it to the data frame. But yeah, you can use any variable name. It doesn't have to be mask.
Appreciate it.
Any other questions? I know it was super fast and it assumes you already know a little bit about Python.
So when you're dealing with large sets, is there a way to verify or validate that the data that you're importing from Python or from other problematic format is being actually, correctly imported?
So you have to kind of look around. I mean, there are different ways depending on what you're trying to validate. So here, the way I saw these issues was really just by like looking at the data frame and kind of seeing where there are issues and unexpected values. So we know like we had these rows that were extra, we had rows that had calculations in them, and we want to remove those. You can do different things. So you can look at slices of the data. You can actually plot the data and see if you're getting plots that make sense or not. And then you might know you have something wrong with the data that you've imported. We didn't get a chance to get into plots, but some of that content is also in this notebook. You can do different statistics. So if you know a little bit about the data already and you expect to be able to do a calculation on a certain column that gives you a certain result, you can try and, add the values in a column or subtract the values from one column from another and see if you're actually getting the results you expect. So there are different ways to try and inspect whether or not the data you pull in is actually what you formatted the way you expect it to be. Does that help?
Oh yeah, thank you.
Okay. Oh, Jamie, you're muted.
Oh, no, I was just looking in chat. Charles actually saying thank you, and he's probably going to have to take a look at the recording and he said thank you for helping them understand Python more. So Anna, if there aren't any further questions, I just want to make sure one more time. Then Anna, thank you so much for joining us and sharing with us your vast amount of information. The GitHub link, as well as the GitHub link has been added to our Discord, but I will also be adding it to the event site as well as the recording as soon as it's ready to go.
Yeah, and I tried to include a lot of documentation in the notebook, so hopefully that'll help with things. Good luck, everyone. Thank you.
Thank you.